Hello and welcome. We are going to continue to look at mains electricity, but this time we're going to look more closely at safety with the uses of fuses and circuit breakers. So in a previous video we talked about these two types of cable that might be used to connect to your appliances in the house, and we called this one a 3-core cable and this one was a 2-core cable. Okay, and that's simply because we've got 3 wires inside this one and 2 inside this one, and the kind of devices that we use to connect these two are slightly different. This would be used to connect to appliances that are what we call double insulated, and the most common example for that is a hairdryer. Often comes up as an example. It's basically any appliance that has an outer casing that is not metal. Okay, so this is a 2-core cable, and we'll see how that's connected in a minute. 3-core cables are usually connected to appliances that have metal casing. So the common example here is a kettle, but we also have things like washing machines maybe, or toasters. These often have metal casings, and this earth wire is important for those sorts of things, and we'll talk about why that is in a moment. Okay, so we have talked about how a plug is wired up. We have our fuse and our pins and our different colored wires. We said that this one on the right hand side was the live wire. The brown one on the right is the live wire, and this is potentially quite dangerous because you could get an electric shock if you were in any way connected to this. Now, how do we prevent that from happening? Well, this earth wire is important, and we'll talk about that now. So we have our 2 examples of devices. Here's our hairdryer, and as we said, we've got our 2-core cable, and those are brown, live and neutral blue on the left, and it's connected like this. We don't require any earth wire because what we basically have is a double insulated device here. That means that there is no way that this live wire could actually get in contact with the casing, and therefore it can't actually get in contact with you. There are 2 layers of insulating plastic that protect you from the live wire or any live connection in there. Okay, so this is particularly important for something like a hairdryer because you might be using this perhaps with wet hands or something like that, and so it's very important that it's kept as safe as possible and that you don't get an electric shock. Now, with something that has a metal casing, for example a kettle, this is a slightly different scenario. You would see it connected like so. Now, you wouldn't see the colors. I've just put the colors in there just so that we know what's going on with what, but we have the live wire that goes into the kettle, comes out and joins to the neutral wire, and that provides a circuit which creates the heat to heat your water. Now, if I was just to add in a couple more details so you can see a bit more clearly, you might see it wired up like this. So you can see the live wire there carries the current in, and it comes back out and through the blue wire there. Now, we did say in the previous video that the mains electricity is alternating and the current constantly changes direction, but there are some fairly complicated reasons to explain why this is always live and this is always neutral and this is the dangerous one, which you don't really need to know details about. But for the purpose of this, imagine we've got the current that comes in from the live wire through, heats the water and happily goes back into the neutral, and it does the job as we want. Now, sometimes what can happen is the live wire over this side can maybe sometimes become loose or wear away or something and become connected to the casing. So what could happen is this could become loose and somehow touch the casing of the wire. Now, that causes a slight problem because that means the whole case, the whole metal case, becomes live, and you could come along and, excuse the scale here, obviously this is not the right scale, but you could come along, you could touch that outer casing, and the current, instead of flowing through the neutral wire back into the plug, would and could actually flow through you and give you a severe electric shock that could be very harmful. The earth wire prevents this from happening because what the earth wire does is it's also connected to the outer casing, and what would happen is if the live wire became in contact with the outer metal casing, the current would not flow through somebody that touched it. The casing wouldn't become live, but what would happen is the current would then be directed through the earth wire back into the plug and literally into the earth, into the ground. Okay, now what happens there is the current flows through the earth wire, this has a low resistance. This means the current goes up, and that high current surging through the plug will actually make the fuse blow, or blows the fuse. Okay, so that sequence of events is quite important. If the live wire touches the metal casing, the current will then instantly go through the earth wire, which is connected to the metal casing. We have a low resistance. That means if we have a low resistance, the current will suddenly shoot up, and that will blow the fuse very, very quickly. Okay, so that's how the earth wire helps protect you against electric shock for appliances that have a metal casing. Appliances that don't have a metal casing and have a plastic casing often are double insulated. And now there's one more device that we need to look at, and that's called an RCCB, and that stands for residual current circuit breaker. And there's a little picture of one that you might have seen before, so it looks a bit like this. I'm sure you've all seen one of those somewhere before. But a residual current circuit breaker is designed to give another layer of protection for certain circuits. A lot of the circuits that are connected in your house are connected through a residual current circuit breaker, so that if anything goes wrong, they switch off the current straight away. One common example again is with the use of a lawnmower. These are often connected via a RCCB, and the reason for that is it works with quite a large current, but you're also working sometimes with wet grass. You're working with these blades that spin, so we could possibly cut the cord and then expose you possibly to that electricity. We could also have a metal casing that might become live, and if you touched it again, you could get a shock. But a residual current circuit breaker is used in instances such as lawnmowers, which could be possibly quite dangerous. And the way it works is that it detects a current between the live wire here and the neutral wire. Okay, so imagine we had a sudden difference in the current between these two. Let's say this was 4.0 amps because of a surge, and on this side there was 3.98 amps. You can see only a small difference in the current, but enough to trip this RCCB, and that would switch it off straight away. Okay, now the big advantage of using an RCCB compared to having a fuse in a plug is that an RCCB is much quicker, much faster than the fuse, and therefore will cut the current off very, very quickly. But also it can be reset. So all it has on it, you may remember from the picture, all it has is a little switch. As soon as that cuts off the current, you can investigate, make safe whatever the issue is, and then just switch it back on and you can use it again. Obviously with the fuse you can't do that. You have to go through the palaver of opening up the plug, finding the right fuse, switching it, and reconnecting it all. Okay, so two big advantages of the RCCB there, and basically works by detecting a change between the live and the neutral wires going into an appliance. Okay, so that's an overview of safety with mains electricity. That's me done for this video, and I'll see you again soon.